Alright, so applications of marginal analysis. Okay, so this is just kind of putting it all together, finding your partial derivatives, plugging in numbers, and interpreting it using marginal analysis. And remember, it's the interpretation that we're looking at here. Alright, so suppose a company has two different styles of baseball uniforms, modern style and throwback. So they produce X modern and Y throwback each week for a total profit of that in dollars. Alright, so the first one is just the profit function at X equals 125, Y equals 200. So it's just taking those in. And again, the biggest thing about this function is there's just a lot of numbers to keep track of. So make sure the X goes in the X part and the Y goes in the Y part. So again, there's just a lot of moving parts. So just make sure you're careful when you're typing this out on the calculator. It's really easy to mistype something. I have enough room on here for my 50,000. Alright. Comes out. Alright, so again, interpret its meaning. Right, there's the number, blah, blah, blah. You plug it in the calculator. So when they sell 125, again, I'm assuming this is averages, sell 125 throwback, right? No, modern. X is modern. Modern. And 200 throwback uniforms a week. The total profit, right, it's weekly, right? Yes, total profit is 353750. Right, so that's just, they sell 125 per week, 200 per week, and we're assuming it's average sales. They'll make a total profit of $353,750. Alright, so that's just algebra. The calc part. So find the derivative, plug in the same x and y values, and then again, this is sort of the bulk of this. So if this were a 5-point question, 2 points would go to your derivative and your numbers. 3 points would go to your analysis. What does it mean in terms of marginal analysis? Alright, so find your first order derivative with respect to x. So f sub x. Well, I'm just looking at the x part, so I get negative 4x, that zeroes away, 30y plus 200, the rest zero away. Plug in my current level of production and sales. So again, I plug in my x and my y values. Be careful where you plug in your x and your y values. Alright, comes out. So when I plug those in, 5,250. Alright, the interpretation, there's 3 parts to the interpretation. What's changing, what's being held constant, and at what level, because it mattered, right? If I plugged in different numbers, so if instead of 125, I plugged in 120, and instead of 200, I plugged in 100, it would change my number, right? It would change, because I'm multiplying by those 125 and those 20. And so it matters what level I'm at. So those numbers are important in my interpretation, my explanation to the reader. So if they increase the weekly sale of the X value, which is the modern uniform, from 125 to 126. So the sales go up by 1, but specifically that one, from 125 to 126 a week. Alright, that's important, because I did use that number in my math. And they hold the sale of the throwback uniform constant. Not just constant, but it's constant at a specific level, and it mattered, right? The 200 multiplied by the 30, that was a big difference. I would get a lot different number had that been 100 versus 200. And so it mattered that not only was it held constant, but it was held constant at 200 uniforms. At 200. Alright, that they sold 200 of those a week. So what's changing, what held constant, and how does that affect my overall function? My overall function's profit in dollars. And so then profit will increase by about, alright, total profit will increase by about 5,250. Alright, those are the three things we're looking for in your interpretation. Alright, well I'm going to do the same thing, but now in terms of y. Alright, so I'm going to find my derivative of y and then plug in the same x and y values. Alright, so the derivative with respect to y, so I get negative 24y plus 30x, and I'll double check that, but I believe that's what it was. Negative 24y, 30x plus 700. Alright, then you plug in your x and your y. So piece of y at 125, 200. Again, make sure you're careful. It's negative 24 times 200. A lot of times students will put the wrong value and they'll put 125. Make sure y goes in the y spot. 30 times x, which is 125. And again, often students will flip the x and the y in this case because they're in a different order than what they're used to. Right, this time, for whatever reason, the change is in the negative direction. Comes out negative 300. And profit can have a positive change or negative change or zero. Zero would be no change. Alright, so if they increase, and again I'm going to guess it's a cost efficiency thing. Alright, so if they increase the production and the sales of throwbacks from 200 to 201. Again, it would be different if it was a different number, right? So we'll actually plug 200 in. And hold the modern constant, not just constant, but constant at a specific value, 125 per week. Then profits will decrease by about 350 for whatever reasons. Alright, again, maybe it's a cost efficiency thing. Alright, so those are the three things that we're looking for when we're describing marginal. So again, three things. What's changing? At what value is it changing? From what number to what number? What's being held constant? At what level is it being held constant at? Because it matters. And how does that affect my overall function? Is it increased by how much? Decreased by how much? I'm going to go ahead and do the last application. And maybe I'll do the next application in the next video.